Hello dear viewers, welcome to Dashing Edu. Today I am going to discuss a very important chapter and issue, and it is interconversion of solid, liquid and gas, which is essential for the preparation of O and A-level chemistry and physics students. Also, the SC and SSE students who are studying English version, physics and chemistry. So today's discussing point is interconversion of solid, liquid and gas in terms of intermolecular forces of attraction. Now the question is intermolecular forces of attraction. Before going to discuss the issue, let's know about the intermolecular forces of attraction. You know, we are on the Earth's surface. We cannot fall down because of the gravitational force between the substance on the earth and the center of the earth. But here the force which pull each particle to another particle or each substance to another substance on the earth, this force is called the forces of intermolecular or interparticular forces of attraction. That's why one substance attracts another substance, or one particle attracts another particle. So today I'd like to show you the arrangement of the particles of three states of matter. Let's see the arrangement of the particles. Here you can see the particles in the solid. They are arranged regularly, so no gap, tightly packed. Why is this the case? Because of strong forces of attraction. The interparticular forces of attraction are high. So they are tightly packed together. So when we want to convert this solid into liquid, what we need? Actually, to convert this, firstly we need to lessen the forces of attraction between the particles. If we can do so, the particles will vibrate and at a certain period they'll move around themselves. So for this reason, to lessen the intermolecular forces of attraction, we should supply external heat on the particles of the solid. And when we heat them, the particles firstly vibrate, and if we continue the heat, then the particles move and vibrate faster, and at a certain period the intermolecular forces of attraction become less. As a result, the particles become move, but they are still in touching. Look at this, look at here. So they are still in touching, but some gaps are formed, so they can move around themselves. So this happens due to the heat, due to the less force of attraction between them. But the forces of attraction between the particles are not so high such that the particles can be detached from each other. They are still linked to each other. So this happens when the forces of attraction become less between the particle. So we know this happens due to the external heat here. So when these particles start to move around themselves, at this point, if we measure the temperature, we get a certain temperature, and this certain temperature of the substance is called melting point. That means when the particles of the substance starts to move or starts to melt, this is called melting point. The condition of, let's say, the condition of the liquid. Here gaps and random particles are random, still in touching. We should bear in mind that the particles in the liquid are still in touching, though they can move around themselves, and there are some gaps. That's why it is diluted, it is liquid, it becomes liquid. So here the forces of attraction less. Now what happens if we heat further? What happens? After a certain period, the forces of attraction in the liquid become more or less, and the particles, due to the more heat, the particles become move and faster and faster, such that the particles become separated, detached from each other. Here, look at this. No attachment. They are separated. Why is this the case? Again, we should say the forces of attraction. The factor is forces of attraction. The forces of attraction between the particles are almost nil. That's why they can move freely in all directions. So this phenomenon is called boiling. Again, when these particles, due to the heat, due to the boiling, it starts to get high speed and detached from each other. And if we measure the temperature at this point, we get a definite or particular temperature. This particular temperature is called the boiling point of the substance. So we have got the gas state. Now simply the reverse case happens when we want to get liquid from gas and solid from liquid as well. So let's see what is going to happen here. Here we have seen the forces of attraction almost zero. No forces of attraction here between the particles in a gas. That's why if we can bring the particles back together or closer, then what we need to do? We need to reduce the temperature here. We can cool the particles. If we reduce or cool the particles, then the particles again come in contact each other. That means the forces of attraction between the particles regain, such that the particles again attach to each other. That means the gas starts to form a liquid, and this phenomenon is called the condensation or condensing. That means the forces of attraction in liquid gain, but still the forces of attraction less, not too strong. So when these forces of attraction can gain more, stronger, then solid form can be obtained. So what we need to do? We need to do is to freeze or to reduce the heat more from the liquid particles. So When we cool further, the particles become closer together and they get the regular shape. The particles get the regular shape again. That means the forces of attraction have become stronger. This is because the particles are tightly packed. So this phenomenon is called freezing. Again, when these particles start to be closer and get strong force of attraction, when we measure this temperature, then we get one temperature, and this temperature is called freezing point. Interesting thing is that the melting point and the freezing point of a particle substance are exactly the same. So this is how the substances, solid, liquid, and gas can be converted. That is until the next episode will be held with another important issue. Till then, bye. Don't forget to subscribe my channel and like, comment and share. Thank you. See you then.